Hello everybody. All right, so today's class, I've got a bunch of things I want to go through. First up, a little bit of news. Assignment 4 has also now been posted. Of course, last week I posted assignment 3, which is due at the end of this week, and assignment 4 is going to be due Friday, June the 12th. The other piece of information is I'm in the process of planning a test. So I will keep you posted on that, but definitely in the next couple days, I'll be giving you some details about when the test will be. Obviously, I'm going to give you guys a couple weeks notice for the test, but just keep a lookout for that. All right. So assignment 4, as it is mentioned here on D2L, this assignment is going to cover outer joins, as well as set operators. So these are some of the topics that we've recently covered. We covered outer joins in the last class, and today I'm going to go through and do set operators. And of course, it'll also have probably a little bit of stuff on inner joins as well. Okay, so now that that's out of the way, let's just do a quick review. So I'm going to go to assignment 3. And I'm just going to pick one of these questions. So I think I'll pick question 5 here. So this question basically is going to, let's see here. Using the AP user, create a query that displays 4 columns: name, total credits, and balance due for all invoices with a balance due greater than or equal to $500. We need to use the join on syntax, and we also need to sort the balance due in descending order. And then they've got the headings for this, this query right here. So let's go ahead and do this query together, kind of as a review exercise, but also it might be a bit of help if you're doing the current assignment and having a bit of trouble. All right, so I've got my SQL developer open here, and I'm just going to maybe adjust the screen here so I can hopefully see both of these at the same time. Okay, there we go. There we go. All right. Okay, so first off, I need to go to I'm using the AP user. So I need to go to my other users, and I have this C hash sign AP. That's the user I want. So I'm going to open this up, and I'll see here my list of tables that are included in this with this user. And looking at the question, I need to look at the vendors and invoices table. So I can, the first thing I'm going to have to do is I'm going to have to make sure I'm connecting to the AP user. So I'm going to write connect. And I put in the username, and then the password is AP. And now I can go and do my query. So we'll just go through and do basically each column to begin with. So the first one I want is going to be vendor name. So select vendor name. Then I want invoice total. Then I want sum of payment total and credit total. Now, I'm just assuming that the columns they're giving me are correct. I could also go and look these up. So these would be from the invoices table. So I would just double click this, and you can see the names and the data types of each of the columns. So we can verify pretty quickly that there is a payment total there. There's also a credit total, boom. And there's also an invoice total as well. All right, so let's continue. So we've got invoice total, and now we need the sum of the payment total plus credit total. Now, this arrow here, this arrow pointing to VName and total and credit, these are column aliases, so I also need to include those. So I'll say vendor name as, and it's going to be VName. And invoice total as total, payment total plus credit total as credit, And the last one I need is invoice total minus sum of payment total and credit total. So this one's it's a little bit confusing how it's worded, but this is how I would do it. I'm gonna go invoice total minus, now we need to subtract the sum of these other two columns, so I'm gonna use parentheses. So minus payment total plus credit total. And I'm going to call this balance due. Okay. And now I'm going to put in the two tables. So I want from vendors. Now I'm going to give this a column alias. So that means I have to go up here to my vendor name because I'm using a column alias and go v dot vendor name. And so I have vendors v join, and I'm joining this with invoices I. So I'll go up here and I'll add my table alias of I in front of all of the columns. Okay, so that looks good. And now I have to do my join on, and I'm gonna say I'm gonna join them on the vendor ID. Because if I look at both of these tables, I believe, obviously vendors has a primary key of vendor ID. And then when I look at the invoices table, it also has a vendor key column as well. So that's what I'm gonna use to join them. So v dot vendor ID equals I dot vendor ID. Okay, I'm just gonna run this query, and there's a few more things we have to do, but let's just run this to make sure we're on the right track. Okay, there we go. And we can look at this data just to examine it and see what it's doing. So for example, we see a invoice we've got from a different vendor, and we can see the credit, in other words, how much we've paid or put towards this invoice. And then the last part is, well, what amount is remaining. So based on these numbers, this looks like I've got this set up correct. So the last part I need is I need to only do this for invoices that have a balance due greater than or equal to $500. So for that, I'm gonna go where, and I'm now going to say, I'm just going to copy this column here. And that's greater than 500. And the last part is I want to sort the balance due in descending order. So order by, and the column alias name is balance due. And I need to order in descending order, so I use the DESC keyword. And let's try this out and see if it works. All right, so the mistake that I made, because balance due is the column alias, I need to use quotes around it. And now when I run this, there we go. We get a result, and we see that there's 12 rows selected. And when I look at the balance due, I notice that these are all greater than 500 for the balance due. Okay, so the idea there is just to do kind of a review exercise. This, of course, helps you guys with your assignment. So at this point, I think we're ready. We can now move on to the next part of the lecture. All right, so I don't have any new notes for today, but under lectures, for lecture 8, self-joins and outer joins. All right. So just to quickly review, last class we went through self-joins, basically where a table references itself. We did a few examples of this. This is a fairly rare type of query. It does come up though. So the example that we did was where you have a customer table where the customer has a primary key of customer ID, but there's also a column that is the referred column, and that also has the same data type as a customer ID, and basically contains the customer who referred you to the store, I guess. So one of the queries that we could do would be to print out all of the customers who have referred someone. And to do that, you would have to do a self-join. In other words, you had to join the customer table to itself. All right? So please go back if you're not clear about how self-joins work, and take a look at the previous video from last week, where I did some examples of this. All right. So the other topic that we looked at last class was outer joins. So just a quick review. When we do inner joins, this is the most common type of join where we have two tables and we basically join, create rows based on, we grab columns from one table and columns from another table, and we join them together when we have a match. So we only grab the columns from each table when there's a matching condition. However, in an outer join, we would grab all of the columns from one table, even when there isn't a corresponding match in the other table. And an example of that would be what's called a left outer join. So in a left outer join, the table on the left of the join command, all of its columns are matched. Okay, and only the columns on the right table that actually match the condition get added, but all of the ones on the left. So you often end up with a bunch of values from the right table that have a value of null because there was no matching condition. Okay, so once again, if you're not quite sure about this, look at some of the examples we did in the last video. Okay, so let's just continue on. This is where we left off, and this is joining 3 or more tables. And I believe for the current assignment, there are some questions where you have to join 3 or more tables. So this will be some good practice. It's really not a very difficult thing. Once you've joined 2 tables, joining 3 is really no big deal at all. Okay, so they've got an example here. We want to know the name of each book that has been ordered by each customer. The detail line must be, so the detail line, basically the names of the columns, must contain the book title, the customer first and last names. Okay, and this can only be from books that have been ordered. So this will require the following information from 4 tables. So we need the customer table, we need the order table, the order item, and book table. So 4 tables in this case need to be combined to basically grab the data from each of the tables to combine them to get this information. Okay, so I'll just minimize this a little bit and we can go through and do this example in SQL Developer. All right, so I believe this is from the bookstore table. So we see we have customers, we have orders and order items and books. So this will be these are the tables we'll use. So I'm going to create a new database file. All right, I'm all ready to go here. Okay, so because we have 4 tables in this case, we need to see how each of the tables can be joined together. And to do that, basically each pair of tables, there needs to be a common column that has the same data type that we can use to join the data. So for customers and orders, if I open up these tables, So there's customers there. We have a customer number. And if I go to the orders table, we also have a customer number there. So that can be used to join those two tables. Now with orders and order items, we have this order number. So order number is the primary key for orders. And for order number, for order items, order number appears to be a part of the composite primary key. So we can join these tables that way. Then we also have order items and books. Now order items has an ISBN, which is an identifier for a book. And if I look at books, we also have an ISBN. So we can use these common columns to join these tables together. Okay, so here is our query. So select last name, first name, and book title from customers, orders, order items, and books, where customer number equals, well, basically the customer number equals the order customer number, and the order number from order and order items is equal, and where the order items ISBN equals the books ISBN. Okay, so just to review, this query is going to print out all of the books for each user, for each customer in the database. And the only way it can know which books are related to which customer is to look up the information from the order, and that information is the order items, which are each of the books that were ordered. So that's what this query here does. So let's try this query out. So I'm going to go select c.last name. Okay. Now, of course, this is using the traditional method of joining tables. Of course, we would much rather use the join on because it's more explicit. It's much more clear what's going on. All right, so I'll just continue here. Customers C. C.customer number equals O dot. Okay, and we're also going to order it by the name. Okay, so let's try this out. All right, I always make this mistake. So it's B underscore. Okay, and there we go. We can basically see that all the books, so for Kenneth Fella, they've ordered Painless Child Rearing and Cooking with Mushrooms, okay? Tammy has ordered a whole bunch of books, right? We can see those. So basically each book that's been ordered by a person is output. Okay, so let's continue on. Now keep in mind that is the traditional method of joining tables, basically the outdated method. They're probably going to show us now, oh no, okay, no, they're building on this. So now they're basically saying only display books that are of the category computer. So all we would have to do is add to my where condition, I'm just going to do another and I would say and category equals computer, and I run this again. And now only computer books, right? We can recognize database implementation, Holy Grail of Oracle. Okay, sound like some really exciting books here, guys. So basically we've just added a filter using a where clause. All right, and then of course, as I figured, they're gonna show us how we could modify this query. So it uses the join on syntax, And the assignment does that as well. It'll say do this in the traditional method, do this using join on. So we can quickly go and do that. Basically, I just need to, instead of using this where clause, I do this in the from. So from customers C, join orders O on C dot customer number, equals O dot customer number. Okay, and now I'm going to join the next set of tables, which is order and order items. So I would then go join order items OI on, and that's then going to use the order number. So O dot order number equals OI dot order number. And then the last join I do, I'm going to join the order item with the books. So the order I do this is very important, that I basically have to put them in the order that the tables are joined for this to work. So now I'm joining the last table that I wrote down here, which is order items, and I'm joining that with books B on OI.ISBN equals B.ISBN. Okay, and I can remove this bunch of things from my where clause, and all I need to leave is where category equals computer. So let's try running this. Okay, I got an error here. Okay, C dot category. Okay, there we go. Okay, there we go. So we get the same results. So obviously this is I think a nicer way. I've mentioned that before. Just makes it more readable to use the join on syntax. Okay, now I'm not going to go through and type these out, but I recommend you guys take a look at them, try them out. You can also use the natural join because the reason why is because in this case the columns that we're joining have the same name, and there's only that one single column between these tables that is the same. So that allows you to say natural join, and you save yourself a bit of typing because you don't have to specify which column, because Oracle will pick out the column to join. Okay, and then there's also the join using. Basically kind of similar to the natural join. If you have columns that have the same name, you can use join using and just specify the column you want to join with. The advantage this has is it's more explicit. When you use natural join, sometimes you can make a mistake because you don't realize there's another column that is going to end up being used for the join condition, which you probably don't want. So join using is a little bit safer. All right, so we're moving on now, and we're now going to look at set operators. So basically, with set operators, we can combine the results of two or more select statements. So we could have a select where we grab a bunch of columns, and maybe that's going to grab, say, 10 rows. Then we have another select that's going to grab maybe 15 rows. So by using the union set operator, we're going to combine the 10 rows with the 15 rows, and most likely we'll get a set of 25 rows. Now it turns out when we do that, if there are any duplicate rows, they will be removed. So we might get less than 25. If we want to keep the duplicates, which usually we do not, we would use union all instead, okay? The intersect is different in that what it will do is it'll take, maybe there's 10 rows from the first select and 15 from the second. It'll only grab the rows that are in both, okay? That are in both select statements. So you're gonna get a much smaller result. And then the last one is minus. So let's say I had 10 rows from my first select statement and I had 15 again from my second. If I did a minus, and I subtracted the second set from the first, if of that 10, maybe 3 of them were in that second 15, it's going to remove them from the first select, and I'd end up with 7 rows in my result set. So these are actually fairly simple operators. And I just also should mention from the book that these are contained in chapter 4, and this is from page 150 to page 155. So it's only 5 pages, and definitely a good way to study and learn some of this material is to read parts of the book. Chapter 4, pretty much that's what we've been covering lately, doing joins, inner joins, outer joins, and now working with basically set operators. Okay. So let's go through these slides. We can do some examples. So basically the 4 that we're going to look at are union, union all, which is almost the same thing. It just means that union all, we're not going to remove duplicates. Then we have intersect and minus. So the union will be the first one we'll look at, and this will return the result of both queries, but duplicates are removed. All right. So here's an example where we are selecting the author ID. So we have 2. Let's just quickly pay a bit of attention to the syntax. We have 2 select statements. So we have this first one, and then we have the second one. All right. So for the first one, we're selecting the author ID from books, and we're joining books with book author using ISBN. So in other words, we're basically only going to grab author IDs that have actually written books, okay? And we're also gonna filter that with a category of family life. So now this first query is only gonna return author IDs who have written books from the family, from the category family life. Now the second select statement is going to grab author IDs, and it's going to join, once again, books with book author. So this means that we're only going to grab book authors who have actually written a book, and we're then going to filter and only grab books from the category children. So the first select grabs authors who have written books about family life, and the second one grabs authors who have written books about children. And because it's a union, basically you're going to combine the set of rows. Now, one thing that's really important is that you need to have the same number and types of columns for this to work. So obviously this is the same column. Book author, author ID, that's the same column that's being returned. So we know that it's going to work. But if this was a different column and it had a different type, we wouldn't be able to get this to work. Or if there were a different number. So for example, if the first select query, say, it has 1 column. Let's say the second one had 3 columns, okay? Then it's not gonna work because Oracle is not gonna know how to combine these rows when one row has 1 column and the other one has 3, okay? It makes no sense. So the union, there are some restrictions on how you can do this. Okay, so let's do this example really quick. So let's do the first, so I'm going to go select ba.authorID from b_books b, join b_book author ba using ISBN where category equals okay, so I'm going to run this. All right, and there we go. We get a result set of 4 rows. Oops. So let's do the second select statement now. So the second part is, actually, you know what? I'm supposed to copy this. I'm not typing it all out. Okay, and the only difference is the category is children. And we run this, and we get two rows. So the whole idea here is now we're going to combine these by using the union operator. So now when I run this query, oh, that's because I had the semicolon. Okay, let's run it again. Okay, so now basically we've illustrated that the first set gives us 4 rows, the second gives us 2, and we're going to combine them using the union operator, and there's no duplicates, so it ends up returning those. Now, let's just pretend, for example, that we did do some duplicates. So let's have the first set still use family life, but now the second one uses family life also. So now when I run this, you can probably guess I'm only going to get 4 rows because the duplicates are removed. But if I change this to union all, now the duplicates won't be removed. And I'll get 8 results. There we go. So it's allowed to now duplicate those results. Okay, and of course, I anticipate what the notes are going to say. So they just illustrate the union all. Okay, so let's just see here what is the... Okay, so they do the union all. Union and union all operators can have more than one operator. So I think what they're saying is that we could do... I think what they're saying there is you could do something like this. So right now we have one union operator, and we're basically using it to combine 2 sets. But it's unlimited. I can keep adding more. So I could go union again, and I can now do another select, and I'll grab some more rows that I will combine. So now I'm going to say category equals computer. Okay, and I'll run this. I'll change this back to children. Okay, there we go. So we've now got the children books, the computer books, and the family life. Okay, so the one thing that they're showing here in this example, they're using the asterisks to select all of the columns. So they're grabbing this from publisher and they're doing it from publisher 3. Now, as long as these 2 tables have the same number of columns and the columns match, then the union operator will work. So they do publisher ID if they were to join them. Now here they're specifying a publisher ID and name, and then an ID and name from the other publisher table. And that works because the ID is the same type as pub ID. So it allows that. One thing you'll notice though is it takes the name from the first select. So when we look here at what the column is named, it's going to be named based on what is placed in the first select statement. Okay? So even though this second one has a different column name, it doesn't get reflected in the results. All right, so here's some rules. And the book probably does a better job of explaining this if you read through, as I mentioned, from page 150 to 155. But each query has to have the same number of columns. And they also have to be in the correct order. Okay, so if you were to take that previous query, and if the second select, if you went name, then ID, it's not going to work. Okay, columns names can be different, but they have to contain the same data types. And these are rules, they call this union compatibility. Okay, so moving on, now we're going to look at the intersect operator, and this is going to return the records that both row sets contain. Okay, so it has to, if you have a select and then you have a union and another select, the rows that will be returned after the intersect have to exist in both of those select statements. So this one here is select customer number from customers, select customer number from orders. So in other words, this is going to only return customers that have placed an order. Okay, so let's do this one, I guess. Okay, so I'll do the first one. Select customer number from B customers. Okay, let's just run this and see how many results we get. Okay, so we get 20 results, and then let's do the second one. Select customer number from B orders. Okay, we get 21. All right, now I'm guessing that some of the customers have ordered multiple times. So when I union these, I'm probably going to get a smaller result. I'm guessing I'll get something, although I don't see those numbers repeating. Okay, so let's try it. Let's see how many we get. Okay, we get 20. Okay, so it looks like pretty much all the customers have placed an order, apparently. Okay, so select customer number from customers, union that. Oh, I know why, I'm using union. I'm supposed to use intersect. Okay. So union would have just combined them and only removed any ones that were duplicated. Intersect, though, is only going to return them if they exist in both selects. Okay, so 14 customers have placed an order, all right? All right, so let's keep going. Okay, now we're on to the minus operator. So the minus operator will remove the results of the second query that are also found in the first query. So only rows in the first query, the first select, that are not contained in the second one will be kept based off of the minus operator. So this one is, you can probably guess what it's going to return. It's going to return all customers that didn't place an order. So this is going to end up with, I think there will be 6 customers, because I think there were 20 customers total. And we know that 14 have placed an order. So now when I change this to minus, and I run this, there we go. We have 6 customers that have not yet placed an order. Okay, so this last table here, this is kind of goes along with set theory. So if you were to look up the set operators of intersect or union, you would see some of these what are called Venn diagrams. So this basically just illustrates some of the concepts. This is kind of a visual way of seeing what we're doing. So I'll try to go through these really quick. The first one is a left join. So when you do a left join, you're going to have some rows that are in both, that come from both table A and table B. And we can see that part in the middle. But because it's a left join, we are also going to include all the rows from table A, all right? They're going to be matched, even though there isn't a corresponding match in table B. So that's a left outer join. Now, a right outer join is the same thing. It just mirrors it. So in other words, rows in table B are going to be matched, even though they don't have a corresponding match condition in table A. And only rows in table A or columns in table A that contain a match are going to be included. All right, now we have our typical inner join right here in the middle. So we're only going to include columns in table A and columns in table B when they have a match. All right, so in other words, the join on, that on condition has to be true for both the columns in table A and table B for us to basically return a row. All right, so the other two here, we have this one here. This is a left outer join. The only difference is they've added an extra condition, which is, I don't know why, but this isn't really related anywhere in our notes. They just kind of threw this in here. But you'll notice it says where b.key is null. So in other words, they're eliminating any of the rows where the join condition was true, because they're saying that the b.key has to be null. So in other words, they only want us to keep the rows in A that were added by default and not matched, okay? And of course on the right here, we can see the mirror image of it using a right outer join. So the difference here between the other outer joins is just this extra where they check that the key from the other table is null. All right, there's 2 left here, and we have a full outer join. So when we do a full outer join, we return everything. We return all of the matching columns. We then return any columns in table A that don't match and any in table B that don't match. So that is a full outer join. And then the last example they have is once again a full outer join, but they've also said where either of the keys or the join conditions are null. So they're basically eliminating the inner part of the join, okay? So this is just kind of used as a guide, kind of a way to help visualize the different types of joins that we've been learning. Okay, so I am going to stop here. You guys have lots of work to do right now. We have assignment 3 up. I've got assignment 4 up. So even if you're making good progress with assignment 3, please try to finish it up and get started on assignment 4. I will also be posting information about when we have an upcoming test, and that'll be done hopefully today. Okay, well, hopefully you guys have a great day, and I'll talk to you later. Okay, bye.